Okay, so we're going to prove that if the modulus of z is equal to the real part of z, then z is a non-negative real number. Okay, so if we're talking about the modulus of z and the real part of z, we're going to let z be a complex number, right? So let z be equal to x plus yi, where x and y are real numbers. And of course, we're going to assume that the modulus of z is equal to the real part of z. So what this tells us is this implies, so the modulus of z is the square root of x squared plus y squared, and the real part of z is x, right? Okay, so now we can square both sides to get x squared plus y squared is equal to x squared. We can subtract x squared from both sides to get y squared is equal to 0. And of course, if y squared is equal to 0, then y must be equal to 0. So what we have, so this implies that we have z is equal to x plus yi, but we know y has to be 0, assuming that the modulus of z is equal to the real part of z, right? So this implies that z is actually equal to x, right? But remember, the real part of z is x, right? And we know the real part is equal to the modulus of z. So this is what we have now. So we have that z is equal to x, which is equal to the real part of z, which we assumed was equal to the modulus of z. And we know that, of course, x was a real number, so z is a real number. And we also know that z must be non-negative because x, which is the real part of z, is equal to the modulus of z, which we know is bigger than or equal to 0, right? We know the modulus of z, which is the square root of x squared plus y squared, must be bigger than or equal to 0. So this implies that z is a non-negative real number. And that is the proof.